The World Leg Organization said that the average length of legs in our school is 100 centimeter. And we wonder whether they are true or not. If we measure legs of all people in the school and take their average, we'll learn. If it is 100 centimeter, we say that they are true. But if it is a different result, we'll say that they are wrong. That's all. Now, we'll play a game so that we will guess whether they are true or not without measuring everyone. We'll measure just some people and guess. Let's think in this way. The World Leg Organization claims that the average is 100 centimeters. So, some people have shorter leg, some have longer leg. Then, if we choose some people randomly to measure, let's say 50 people, some people will have longer leg, some will have shorter leg than 100. Some have very shorter, very longer, less shorter, less longer, so their average will become almost 100 centimeter as well. Maybe a bit lower or a bit higher. Then we can guess that they might be true. But if the result we get is not close to 100 centimeter, we can guess that they might be wrong. For example, our result is very lower than 100. We can guess that they might be wrong. But the organization might blame us so that we measure only short leg people. No, we do not. We choose people randomly. For example, from the students list of the school, we didn't see their legs. So, after random choosing, shorter legs and longer legs would be balanced. So, the result would be close to 100 centimeters. But it is not. We think that many people have shorter leg, and so the real average might be shorter as well, as we guess. Now, they might say that each time choosing people randomly, we get short leg people by chance. Ha! It's very unlikely. We still guess that they might be wrong, but it's still a very little bit possible. That's the reason why we say we guess. We don't say they are really wrong. We need to measure all the people to say it. But we can still guess that they might be wrong by asking some people. That's all. Similarly, if the result we find is very higher than 100 centimeter, we can guess that they might be wrong as well. As a result, if we find a value close to 100 centimeter, we can trust them. But if it is farther, we do not trust. That's all. Let's show it with this graph. If the average length we get is 100 centimeter, we are very confident. As we move away from 100, our confidence decreases and almost disappears. So, the result we will find should be close to 100. So, we can trust their claim. That's it. Now, let's talk about how to determine these close values. Let's say that values within here are close values. If we find a value outside of this range, we will not believe the boy. As we can see, our trust is very high in this range. And out of here, our trust is very, very low. That's all. Let's express the same thing mathematically as follows. We actually have some confidence in all values, but values in this range covers 96% of our total confidence. Total yellow area is our total trust, and this is 96% of it. The computer calculates this and tells us. So we say that this area covers 96% of our total trust, almost all of our confidence. So they are reliable, and the rest is ignorable. So if we find a value outside here, we do not believe the organization. That's all. The thing is simple. As we said, we cannot say they are exactly lying. If we measure legs of all the people and find a different number, we can say that they are lying, being 100% confident. But we can still be 96% confident without measuring legs of all the people. And it's enough to have an idea. That's all. Let's do a similar example. We can do it like this. For example, we want to be 99% confident. It's a higher confidence. We'll make an interval at 99% confidence level. We told the computer and it gave us this range. So, if we find any value outside here, we won't believe the claim. And we are 99% confident of our idea. So, we are more confident compared to the previous example. Let's do a similar example. Now, we want to be 90% confident. We will make an interval at 90% confidence level. The computer calculated it and gave us this interval. We won't believe the boy if we find a value outside. And we are 90% confident of our idea. So we are slightly less confident compared to the previous example. That's it. We can make an interval of any confidence level we want.